Answer me this question. How many times can two lines intersect? Once?
Well,
Are there other possibilities?
Unless they're like...
They can intersect as many times as they
How many times can they intersect? So once, you said as many times as they like?
Yeah, like they can intersect an infinite amount of times.
How would they intersect an infinite number of times?
If they're on top of each other.
If they're on top of each other. Okay. Are there other possibilities? If we got one infinite.
Well, if it's like one's straight and one's like... You know.
Nope. Is that it? Is it a hint?
Well, what about like a part?
There's 3 boxes that we gotta fill. 3 times?
Yeah.
You can take 2 lines and make them cross 3 times?
Sure.
It's quite the skill, man.
Just think about it. 2 straight things. I'll just draw all over my notes here. Alright, this would be one intersection. Right? Like Domino was saying. If we took 2 lines and laid them on top of each other, they touch in an infinite number of points. Right? They touch there, and they touch there, and they touch there, and 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 there, everywhere, right? There's one other possibility.
If one's like angled, say 90 degrees, and then the other one's like angled, say like 90.1 degrees.
So kind of like that. Except exaggerated. It would still cross if you kept going in that direction.
Except then the intersect would be like really, really long though.
But it would still be there.
Yeah.
What if you had 2 parallel lines?
Zero.
They wouldn't touch at all. So that's also a possibility, right? So we've got 1, 0, and infinite. There are 3 ways, like we said, that 2 lines can intersect. They can either touch once, not touch at all, or touch an infinite number of times. The first of those ways is called intersecting lines. Okay, on a graph, looks basically like this. Here's a Cartesian plane. You've got one line going one way, and another line going another way. Right? And they only have one point of intersection. Okay? Note that one of the ways that you know you have just intersecting lines is that they have different slopes. They have to. If they had the same slope, they would be what kind of lines? Parallel lines, right? So they have to have different slopes. And also the y-intercepts can either be the same or they can be different. Right? You'll notice in this example that I've drawn, I have 2 separate y-intercepts. But if I had the same y-intercept, I'll draw another example here, then, that would be the same y-intercept. The y-intercept is the point of intersection in that case. Right? So when you're analyzing a set of equations, linear equations, you want to know how many times they intersect without even graphing them. Look at the slopes and look at the y-intercepts. Right? Especially if the slopes are different. They will cross somewhere. That's the key. Different slopes. Okay? Parallel lines. You know what those look like. Right? So on a graph, you've got one line going like that, another line going like that, and they don't cross. If you go infinitely in the positive direction here, they will never touch. They'll never get further either. If you go infinitely in the negative direction, same thing. They have to have the same slope, otherwise they wouldn't be parallel. They also have to have a different y-intercept, because if they had the same y-intercept, what kind of lines would they be? Or how many intersections would they have? They have the same y-intercept and the same slope. They would have infinite solutions, right? If I had 2 lines, I'll draw another red line on top of the green one here. This red line has the same slope as the green one, and the same y-intercept, but consequently that creates the exact same line. Right? So those would be 2 lines that have infinite solutions. Which brings us to the last of the 3. 2 lines that lie on top of each other are called coincident lines. Okay? Coincident lines. These are 2 lines that lay on top of each other. They are, in essence, the exact same line. The exact same equation, just graphed twice. Okay? Everything about them is the same. Their slopes are the same. Their y-intercepts are the same. And they lay on top of each other. And they touch each other in an infinite number of places. Okay? They have an infinite number of intersections. And to graph that, got a Cartesian plane. Here's one graph. And the other guy lays right on top.
He's lazy.
Lazy. Okay?